Let us see one more problem. A particle is in uniform circular motion, moves with the speed v. What is the change in velocity if the position vector representing the particle rotates by an angle theta? So the particle is in uniform circular motion. Let me take the particle is here at the instant. Now this is the position vector representing the particle. Uniform circular motion, so speed is constant, magnitude of velocity is constant, but direction is changes, so velocity also changes. This is v1 bar and its magnitude is equal to v. Now in certain time this position vector rotates by an angle theta. Now the velocity vector is along tangential direction, that is v2 bar in this case, but its magnitude is same as before because it is a uniform circular motion. Now what we have to calculate? We have to calculate change in velocity. So initial case the velocity vector is v1 bar and now it is v2 bar. So change in velocity is equal to v2 bar minus v1 bar. But already I told you we can't do this. Instead of this we will do like this, minus v1 bar, and we have to calculate this magnitude. For this we need to know the angle between v2 bar and minus v bar, and the magnitude of v2 and minus v1 bar is v only. See here, what is the angle between v1 bar and v2 bar? First let us calculate, so that we can go for angle between v2 bar and minus v bar. This is position vector, velocity vector. Velocity vector is always perpendicular to this position vector. Now when the position vector rotates by an angle theta, this velocity vector also rotates by an angle theta. That means this is v1 bar and this is v2 bar. This angle is equal to theta, but we need minus v1 bar. So negative vector of v1 bar, that is minus v1 bar. We need angle between these two. If angle between v1 bar and v2 bar is theta, and v2 bar and minus v1 bar is 180 minus theta. Now change in velocity equal to under root of v2 square plus v1 square plus 2 v1 v2 cos theta. Magnitude of vector will never be negative, but instead of this theta, the angle between v2 bar and minus v1 bar is 180 minus theta, so 180 minus theta we have to write. What do you get? Magnitude of v2 same, magnitude of v1 is also same, so v square plus 2 vv cos 180 minus theta is minus cos theta. In second quadrant, root of 2v square minus 2v square cos theta, and you take 2v square common, 2v square into 1 minus cos theta. So 1 minus cos theta is 2 sin square theta by 2. Root of 2v square into 2 sin square theta by 2 we have studied in basic mathematics in trigonometry. What do we get? 2 into 2, 2 square, so 2. V square is v, sin square theta by 2 is sin theta by 2. This is the change in velocity magnitude. Now let us see another problem. Find the angle between a bar and b bar if a bar is equal to b bar plus c bar, and magnitude of a bar is 5, magnitude of b bar is 4 units, and the magnitude of c bar is 3 units. See what we have seen, r bar is equal to some p bar plus q bar is given, then by taking modulus on both sides we can calculate angle between p bar and q bar directly if we do, if individual magnitudes are given. Here A bar is equal to B bar plus C bar is given. If you take the modulus on both sides, anyway the three vectors magnitudes are given, so directly we can go for angle between B bar and C bar. But the question is, we have to calculate angle between A bar and B bar. That means we have to write the equation so that A bar and B bar must be on one side. That means from A bar is equal to B bar plus C bar equation, A bar minus B bar is equal to, we can write C bar. So here A bar plus minus B bar is equal to modulus of C bar, and he did not ask angle between A bar and minus B bar. He has asked us to calculate angle between A bar and B bar. So let me take, this is A bar and this is B bar, and angle between these two is theta. So this is what we have to find. So we have to get the equation in terms of theta only. That's why I am taking this in terms of theta only. It will be 180 degrees because this we know it has minus B bar. Now under root of A square plus B square plus 2AB cos 180 minus theta. If it is theta, this angle is 180 degrees, so it will be 180 minus theta. Cos 180 minus theta is equal to modulus of C. And substitute the values. A is 5 and square on both sides. 25 plus B square is 16 plus 2 into 5 into 4. 20 into 2, 40, cos 180 minus theta, so minus cos theta is equal to C square, that is 9. I am squaring on both sides and substituting the values. So what I am going to get? 25 plus 60, that is 41, minus 9 is equal to 40 cos theta. So cos theta is equal to 41 minus 9 is 32. 32 by 40. 8 into 5, 8 into 4. So theta equal to cos inverse 4 by 5. So the option is, second option is correct. That means first he has given A bar is equal to B bar plus C bar. Directly if you go for applying parallelogram law, you will be getting angle between B bar and C bar. But he asked angle between A bar and B bar. So we have to write A bar and B bar to one side. This is. Now the question is angle between A bar and B bar. That's why I am taking that as theta. So angle between A bar and minus B bar will be 180 minus theta. Directly I am going to get theta value. That is. Let us see one more problem. Which of the sets or set of vectors given below may represent the magnitude of three vectors adding to 0? That means whether these set of three vectors, if I add them, will I get a 0 value, or whether the set of these three vectors adding to get 0 value, possibility is there or not? Whether the set of these three vectors adding to get 0 value, or the set of these three vectors will be adding to get 0 value. So which set of forces there is a possibility to get the resultant value is equal to 0. Now before explaining this problem, I will explain one concept. From that you will get an idea of this problem. Let us take one example. Here is the object at rest on the smooth surface. Now you are pulling with a force F1, I am pulling with a force F2. Now to get the resultant value is equal to 0 of two forces, what should happen? The angle between these two vectors is equal to 180 degrees. So we know R is equal to P minus Q. That means F1 minus F2 or F2 minus F1, greater magnitude minus lesser magnitude. But what I am asking you, to get the resultant 0, to get the resultant 0, the two magnitudes must be equal and opposite in direction. Under that condition only you can keep the object in equilibrium position. That means whenever you apply the two forces on the body in opposite direction and their magnitudes are equal, then you can keep this object at rest. So the two forces adding up to get 0 value. Now let us go for three forces. The object at rest on the smooth surface. Now I am applying one force in this direction, that is F1 bar. You are applying another force in this direction, F2 bar. So undoubtedly the object to try to move along diagonal side, means along the direction of resultant vector. Now if I want to apply the third force to keep this object at rest, definitely I have to apply the force in such a way that in such a direction it is opposite to resultant of these two vectors. So then only the resultant of these two vectors is balanced by this third force, so that you will be getting a resultant 0. That is F1 bar plus F2 bar plus F3 bar is equal to 0. So F3 bar is equal to, from this, minus of F1 bar plus F2 bar. So F1 bar plus F2 bar is a resultant of F1 bar and F2 bar. And F3 bar must be in opposite direction to resultant of F1 bar and F2 bar. And as far as magnitude is concerned, you take modulus on both sides. So F1 bar plus F2 bar modulus. This is F3 bar modulus. So magnitude of third vector must be equal to resultant magnitude of F1 bar and F2 bar, and the direction is opposite in direction to the resultant of F1 bar and F2 bar. Then you can keep the object in equilibrium position. That means rest. So sum of these three vectors will add up to get 0. So instead of vectors, if I take these three vectors as forces, if I use the term force, here three forces, which set of these three forces will add up to get 0? If you ask me the question like this, then what I do is, this condition must be fulfilled. But according to parallelogram law, as I told you, if R bar is equal to P bar plus Q bar, R bar is equal to P bar plus Q bar, and R magnitude, the greatest value is P plus Q and the least value is equal to P minus Q. So R value must be either equal or less than this, either equal or greater than this. Then there is a possibility to keep the object in rest position. That means either you can take as F3 and the remaining you can take as F1 and F2. That means F3 less than or equal to F1 plus F2 and greater than or equal to F1 minus F2. If any set of forces will satisfy this equation, then there is a possibility to add up to 0. Let me take 2 is F3 either one we can take as F3, that is 2, and remaining 4 and 8. So 8 minus 4, and this is 8 plus 4. 8 minus 4 is 4, so it is not less than 2, so this condition is not satisfied. That's why whatever be the angle between vectors, if you apply these forces, 3 forces on that object, you can't keep that object at rest, means in equilibrium position, and these 3 forces will never add up to get 0 value. Now you can take 8 is F3. Now remaining 16 and 4, so 16 plus 4 less than or equal to here 16 minus 4. So again this condition is not satisfied. Otherwise you can take 4 as F3, so remaining is 16 and 8, so 16 plus 8, 16 minus 8. Again this is not satisfied. Suppose if you take 16 as F3, same 8 plus 4, 8 minus 4. Of course this condition is fulfilled, but this condition is not fulfilled because 16 is not less than 12 or either equal. That's why what I am telling, either one you can take as F3 and remaining 2 will be F1 and F2. So if the condition is not satisfied, then that set of forces can't keep the object at rest in equilibrium position or cannot add up to give 0 value. Next let us go for this. You can take 1, this one I am taking, so this one and 2, so 2 plus 1, here 2 minus 1, so 1 less than or equal to 1 less than or equal to 3. Yes, this condition is fulfilled. Now let us take this 0.5 you can take, 2 plus 1, 2 minus 1, so 1 less than or equal to 0.5. This not satisfied, 3. That's why this is also not possible set of forces for which there is a possibility to give 0 value. But this set of forces, there is a possibility to get 0 value if we apply at proper angles in proper directions.